This is your Lab 1 demo. I'll start by talking about what you need to have open. First of all, you will be able to access the Lab 1 assignment through modules. You'll also need to have your MyStatLab open, primarily because you need the eText as well as StatCrunch. So I'll first open the eText. And what we'll do is we'll work 3 problems from the textbook using StatCrunch. The first one is 1.3, number 12. That is on page 27. So I'll go directly to page 27, and we'll look for number 12. So what we need to do is obtain a simple random sample of size 8, and we're also going to obtain a second simple random sample of size 8. So I'll show you briefly how to do that in StatCrunch. Of course, we don't have a data set here, so StatCrunch is not linked through the textbook. We'll need to go back here to MyStatLab and open StatCrunch. What you'll want to do is just open the StatCrunch website. And what you want is to type or paste data into a blank data table. We are going to be creating our own data set here. So in order to create data, what we need to do is go to the Data tab, and we will simulate uniform data. For the number of rows, we need 8 data values. We typically do some extra rows just because we get repeats here. So we'll say 16 rows of data and 2 columns. That means we'll do part A and B at the same time. So 2 columns there. Now you'll notice if I go back to the eText here, 1 through 44 would be my acceptable values. So that would be the minimum and maximum for my sample. So 1 is my minimum, and 44 is my maximum. And what I would like to do is round to 0 decimal places so that I get whole numbers. Compute. So here's my data. Now you notice I have plenty of values here. I need to take the first 8 unique values. So 20, 4, 38, 40, 23, 24, 4, and 9. So 4 is actually a repeat. I'm going to skip that one, so I'll take 9 and 16 and so on. So watch out for repeats. Take the first 8 unique values for sample 1 and sample 2 in these columns. Now what I need to do once I'm done with that problem, I'm done creating my data, I need to save my data. So the data and all results would need to be saved so that you can include it in your lab report later after you're finished with all 3. So if I click on data and say save, I'm just going to title this lab 1, 1.3.12 and say save. So my data is saved for that one. I'm going to go ahead and close StatCrunch now, so when I go to the next problem, it'll open up again when I open the data set through the textbook. So the next problem, 2.2 number 27, is on page 90. And number 27 is here. The Gini index is a measure of how evenly income is distributed within a country. So we've got values here. We've got lots and lots of values here, so this is much easier to handle with technology than by hand. We're going to do parts A through E, construct a frequency distribution, relative frequency distribution, and a histogram for each of those, then describe the shape of the distribution. So I'll show you constructing the distributions as well as the histograms here. SC is the StatCrunch link, so it will open the data set in StatCrunch. So here's my full list of raw data. So the first thing I need to do is frequency and relative frequency distributions. And in order to do that, I need to do what's called binning my data. So I'm going to go to data, and I'm going to bin my data. I'm going to use the only column I have, of course, and then I will use fixed width bins. So I'll start at 20, and I'll bin with a width of 5. And the rest of this you can leave alone, compute. So here are my bins. And the next thing we want to do is stat tables frequency. We can actually, so what we're going to do is select the bin column that we just created, and we are going to create the frequency and relative frequency distributions at the same time. So you're actually doing parts A and B at the same time. And what we can do, we can just ignore the rest of this and say compute. So here's your frequency and relative frequency distributions. Now options, I want to save. So remember, we're saving data and we're saving results. So this is one of my results. The data, of course, I save at the end of the problem because I may be adding to this over time. But the results I want to save as I go. So my frequency and relative frequency table, I have lab 1, and I'm doing 2.2, number 27, A through B. So I did those at the same time. I'm going to save, close. And I can close this now. It's saved. I don't really need to keep it. But notice here, if I want to reopen it, there's this little 1 here. I can reopen results. So reopen frequency table. So I have those available to me if I want. Now, to create a histogram, we don't use the bins. What we do is we use the original raw data to create a histogram. So we're going to graph, create a histogram. We're going to use the original raw data. And we're going to first create the frequency. We can't do them both at the same time, but they're pretty. The second one is pretty quick once you've done the first. So we'll select start at 20 with a width of 5 for our bins. And we also, it might be useful to put markers in there for the mean and the median because that helps you to determine skew later. Next, what we're going to do is give our x-axis and y-axis labels. The x-axis is the Gini index, and the y-axis label is frequency. And the title of the graph, I'll go ahead and just title this using the problem number. So this is 2.2, number 27, and this is part C. And we want to go ahead and compute here. So here's my frequency histogram. I'm going to save this as a frequency histogram. This is lab 1, 2.2, number 27C, and save. Now that that's saved, I don't have to worry about changing it. So what I'm going to do for relative frequency is actually just go in and edit the same graph. So instead of creating a whole new one, I'm going to just change type to relative frequency. My bins are the same. I want the same markers. My x-axis label is the same. My y-axis label is now relative frequency. And my title is now 2.2.27D. And compute. So now I have my relative frequency histogram, and I can save that one. So for this one, lab 1. 2.2.27D. So I have that one saved. Now I'm finished with A, B, C, and D. Part E is a verbal response question. You'll type that into your lab report during the process of creating the report. You won't do that part here. So now that I am finished with all of my results, I also want to save my data set. Don't forget that needs to be included in your report. So I'm going to save that as 2.2.27. Whoops, put lab 1 at the beginning. Lab 1, 2.2.27. Okay, so I've got my results saved. I've got my data saved. So I can close this now. And I'm going to do the third problem. Now I want to note, by the way, here, if you're looking for the technology step-by-step in addition to this lab demo, it's just usually 1 or 2 pages before the problem. It's right at the end of the section. So in this particular section, it's on page 87. And if we go there, what you'll see is there are a lot of different technologies, but StatCrunch is here on page 87. We have, for discrete data, some instructions, but we're using continuous data, so we're using this instructions here. We're also creating histograms, and so these 2 groups of instructions might be useful to you. So each one of these problems, of course, has a technology step-by-step available. What we're going to do now is go to page 193. And look for 4.1, number 29. So 4.1 number 29 is here. What we're going to be doing is creating a scatter diagram. Now we have parts A and D, which are more like verbal response questions, so determine which variable is the likely explanatory variable and which is the likely response variable. So we have A and B, A and D, where we'll need to type a verbal response in the lab report. For B and C, we'll be working in StatCrunch. So we'll be drawing a scatter diagram and computing the linear correlation coefficient. SC is our StatCrunch link, and that'll of course open the data set right in StatCrunch. In order to create a scatter diagram, first of all, we'll go to Graph, and we'll need to go to Scatter Plot. X will be weight, and Y variable will be miles per gallon. And at the very bottom, you'll get the opportunity to name your x-axis and y-axis labels. So weight in pounds is our x-axis label, and our y-axis label would be miles per gallon. And the title, you can title it again just with problem number 4.1.29, and this is part B. And then we'll compute. So here's our scatter diagram. Again, every result should be saved. So we'll save this, lab 1, 4.1.29, part B, save. And I'll go ahead and close that. The next thing I want to do is correlation coefficient. So what I'll do is stat, summary stats, correlation, and I'll need to select both of these. So I'll click the first one, hold down the control key, and click the second one to select both. And that is all I need to do for this, and I'll compute. There's my correlation coefficient, negative 0.84157,604, and we should all be getting the exact same one here. So what I'm going to do is save my result and call it lab 1, 4.1.29, and this is part C. Save. So that's pretty much it for my results for this one. Not a whole lot going on here, but I need to save my data. So I'll go ahead and save my data. For this one, you haven't done anything to change the data, but I do want it included in the lab report primarily because I want to know for sure that you're using the correct data to generate your answers. So lab 1, 4.1 number 29, save. And now we are ready to create our lab report. So when you finish the last one, what you can do is click the StatCrunch menu and say open statcrunch.com. And you can actually close that data set if you want. We're going to go to My StatCrunch, and you notice you have data, results, and reports. These are the three areas we'll be in. If you click on My Data, you notice you have your 3 data sets that you've saved. And if you click on My Results, here are all the results that you have saved. What we're going to do is create a report. So in My Reports, we want to create a new report. We're going to title it Lab 1, and then type your name. And you'll want to share with everyone so that I have access when you send me the link. And you'll want to give your written responses here in the body area. So you'll have written responses for a few of those in addition to your lab results. Then you'll attach your lab results in the order they were created. So select each one, and then your data sets. You'll also select those in order. So here's 1.3, my data set, and you'll select those in order, and so on. And then save. And what you see here is once you have this saved, you do have an edit link up here in the corner. So you can always go back and edit. So again, just to recap, name your lab with the lab number and your name. Then you need to answer any questions that require a written response, attach your results, and attach your data sets, then save. Once it's saved and everything is there, you can say Mail, you'll use my email address kmcgowan@nmsu.edu, and the subject should stay as the name of your report. You don't need to type a message there. That's totally optional. You can if you want. You absolutely need to switch this link at the bottom, switch this selection at the bottom to send link only. You must send the link only so that I can view the report in the StatCrunch environment. And then you say send mail, and I'll receive that in my email, and you'll get a grade and feedback in the Canvas gradebook.